Welcome back. It's a good problem based on the law of conservation of angular momentum and based on the mechanical energy. Here it is a sphere of mass small m, radius r, and it is a metal bar or rod of mass capital M and length L is initially horizontal position. On releasing this value, it hit the metal sphere. Immediately after collision, find the velocity of metal sphere and what is the m by m ratio. And now the given data is given. Length of metal bar is root 2 r, where r is 6 root 2 by 10 meter. Acceleration due to gravity is 10. Here for elastic collision E is equal to 1. Now see, it is the initial situation when the horizontal bar is come to from horizontal to vertical. Initial angular velocity is given by from law of conservation of energy mg L by 2 equal to half I omega square. Here I is ml square by 3 omega naught square. From that omega naught is root 3g by L. When after hitting this one, the body moves immediately after collision is velocity v for sphere and its angular velocity is omega. By applying the deflection is 60 degree supposed to be or deflected an angle of 60 the given to us. Here by using once again law of conservation of energy, initial energy loss in gain in potential energy equal to loss in kinetic energy, that is half I omega square is mgl into 1 minus cos theta. It is center of mass is at n by 2. So from this one we get omega is equal to root of 3g L by 2 L, and it is omega naught by 2. They are related as omega naught is equal to root 2 times of omega. From coefficient of restitution or Newton's law, v2 velocity of second body v and v1 is r omega. So at the point of this one is c, the total length is L. Here this gap is r. So remaining distance is L minus r. So v1 is r omega for rod. Before collision is v u1 is r omega means L minus r omega naught. Initial velocity of sphere is 0, and from that v is L minus r omega naught plus omega. And by using law of conservation of angular momentum, initial angular momentum I omega naught, immediately after collision is I omega plus mv, r is with respect to the point of suspension of the metal bar. So with respect to this point, angular momentum is applied, then effective distance is L minus r. So here by substituting this I and v is, see here it is L minus r omega plus omega naught into L minus r. After simplification we get m by capital M by small m is equal to 3 by 2. By getting the value of v, here v is equal to L minus r into omega plus omega naught. So by substituting the given data we can get the velocity of ball immediately after collision. The metal sphere is moving with a velocity 3 meter per second. Thank you.